Hello, everyone, and welcome to Black Hat Arsenal. My name is Spencer McIntyre, and today we are going to be talking about a Metasploit framework and some of the latest changes that have come out in version 6.4, which was released earlier this year. My name is Spencer McIntyre. I am a security research manager at Rapid7. I have been involved with the Metasploit framework for quite a while now. I was originally a contributor since 2010. I have worked on quite a few modules. I have worked on some interpreter features, some core features, some of the stuff that we'll demonstrate today, actually, I worked on. And I like to spend some of my free time with my dogs and drawing. But let's go ahead and dive right into Metasploit. So like I said, we're going to be talking about 6.4 today. So we have a number of new improvements. The very first set, though, that I'd like to talk about is some of the latest changes in our Kerberos workflows. So I'm really excited about this because Kerberos was a brand new feature that we originally released in 6.3 last year, but we've gone ahead and iterated on it and made some new improvements to some of the workflows that I am excited to demonstrate today. One of the first up is a new post module which allows exploitation and exfiltration of tickets on a compromised Windows host. So basically, once you have compromised a host and you have a interpreter session running on it, we'll be able to go ahead and utilize this post module. It has a number of actions on it that allow you to check and see the logon sessions and the current logon session. And then with that information in mind, you're able to go ahead and dump the Kerberos tickets from memory. So this might seem very similar to Rubius functionality, but this is integrated into Interpreter, but the idea is generally the same and built on the research that originally came out in Rubius. Now, the approach that we have taken has implemented it into Interpreter via using Railgun, which is particularly nice because that means we are not transferring any extra binaries up into memory. There is nothing written to disk, and there are no new processes. It happens entirely in memory with Interpreter, utilizing the standard API and Railgun, which allows us to make API calls using the Win32 API from our module implemented in Ruby. The downside to this is that it can be a little bit slow. The module might take a little while to run because there's a lot of back and forth traffic between Metasploit Framework and the compromised target that's running Interpreter. But it is a very nice and a pretty easy way to be able to go ahead and access that information. And once those tickets have been dumped, they're actually pulled into Metasploit's very own cache, which allows them to be reused. So you're going to dump the tickets from memory, and they'll instantly become available for you to use from within Metasploit, so you can go ahead and access them and start to authenticate with services with those tickets. One of the really nice things that this allows you to do is go ahead and leverage unconstrained delegation scenarios where you're able to get a ticket and use that to escalate, which we will see in our demonstration. In addition to that, we had the ability to forge tickets in Metasploit 6.3, but we have improved upon that by adding in a couple of new techniques. Originally, we only had the ability to forge golden and silver tickets. We have since added the ability to forge diamond and sapphire tickets. Now, these techniques are typically considered to be more stealthy because they take a TGT and they forge or they modify the pack attribute on the tickets, which allows that information to be rewritten. So what we're going to see is when we go ahead and exploit this, we get a ticket as one user and we modify it to be valid in a different context, which allows us to elevate our privileges there. But it's not really a privilege escalation. Actually, I probably shouldn't have said that because what we're doing is we are using the secret that we have already leaked from the target domain controller, the Kerberos secret, which we will have obtained through the Windows secret stump, which brings us to the third improvement, is that our new secret stump module now supports the pass the ticket authentication utilizing the DC sync target. Now, what that means is that if we have a ticket that grants us the necessary permissions, we can authenticate to the domain controller and we can use the domain action to perform a DC sync action on it and dump all of the secrets out of the domain without needing to know the plaintext password or perhaps pass the hash. By being able to do it through pass the ticket, we have that particular attack, the DC sync attack, fully integrated into our Kerberos workflows, and you can exploit that workflow with the tickets that you have either obtained through credentials, you have leaked them somehow, you have forged them. However those tickets were obtained, you have those in the cache and you're able to go ahead and use those for that authentication purpose, which is pretty nice. So with that, let's go ahead and check out our first demo. So we're going to go ahead and get started here. Now what we're going to do is we're going to exploit unconstrained delegation. So we're first using the LDAP query module. Now we're authenticating as the mHatter user account right here. So this user is just a basic normal user. We're going to use it in a few different scenarios, and we're going to authenticate to the DC, and we're going to enumerate out targets for unconstrained delegation. So we run that and we see 2 targets here. Now domain controllers are always configured for unconstrained delegation, so that's not really interested. But the other one is the workstations, WS01. Now we already happen to have a session on this target, but this is the one we're actually going to leverage. So hypothetically, in the real world, we would have already compromised this workstation somehow. So we can go ahead and we can see our session here. We're already running as NT Authority System, and it's a Windows 11 target. So now let's go ahead and use the new manage Kerberos_tickets module, and we can see the actions that we have here. We're first configuring it to work with the session that we have opened, and we can see that the default action is to dump the tickets. But first, let's go ahead and check out the LUIDs. This is going to show us the current logon sessions, which is going to correlate to some of the tickets that we can pull back. So we can see the current LUID that we have, as well as enumerate all of the LUIDs on the system. So this is where we would look for a ticket that we wanted to access, like a domain controller. We're going to delete all of our tickets out so we can see that we are starting from a position of having no Kerberos tickets. And then we're going to use the Petit Patin module to coerce authentication to that WS01 target. Now, when using the Petit Patin module, it's important that the listener that we're targeting for unconstrained delegation is specified by the host name. And then we're still using that mHatter account here. So when we go ahead and run that, we can see that the attack was successful, and then we run that dump tickets action, and we can see all of the tickets that we have been able to recover from our target. Now, if the attack worked correctly, we should have a ticket in here from the domain controller. So now that we have dumped all of those out, we're going to go ahead and list our tickets again, and we can see the second one from the top is the DC $ at msflab.local. That is the domain controller ticket that we have obtained through unconstrained delegation. So we can use that to authenticate to the domain controller and elevate our privileges through this unconstrained delegation attack. So with that, let's go ahead and use that with the Windows Secrets Dump module. We're going to use that new pass the ticket functionality with the domain action to be able to go ahead and dump the Kerberos secrets out from the target domain controller. So we have this set up, our SMB users configured to be DC $, and we have all the Kerberos data store options set up already. So it's going to authenticate against the domain controller using that ticket that we just dumped out into our cache. So here in our advanced options, we can confirm that we have it configured for Kerberos authentication, and by default, it's going to fetch that ticket out of the cache that we just extracted from memory from the compromised host. Now, want to make sure that Kerberos authentication is set, and when everything is all ready to go, we can go ahead and run this module, and we can see that it has authenticated and it is currently pulling down all of the secrets that we were hoping to obtain. Now with that in place, we can dump out the creds and we have all of the Kerberos secrets. Now by grepping for the KRB TGT, we can go ahead and get the secret value, the AES key for the Kerberos account. Now we're going to copy that to our clipboard because we're going to use this in a couple of modules in the next steps. So we would take this, we're going to go ahead and we're going to copy this because we will need it for forging and inspecting. So now that we are able to fetch that secret, let's go ahead and forge a ticket using the Kerberos Forge Ticket module. And so we are going to use that secret as the AES key. So we can see it's already populated in here as the data store option. I didn't want my demo to be entirely full of me setting all of the different options, but that's where that key came from. We extracted it out of the domain controller by using the Windows Secret Stuff module. So with that configured, we're going to go ahead and use one of the two new actions. We see Forge Diamond and Forge Sapphire here. Now, both of these actions require a request user. So we're setting it to the mHatter user, which again is that basic user. So we're going to request a ticket as mHatter, and we're going to forge it to the S.McIntyre account. Now, we know the S.McIntyre account is a domain admin. We also need to know the domain SID right here, which we will pull out again from the output of the Windows Secret Stump module. Another way to get that would be through the LDAP query. There's a enum domain action that can pull out the SID along with a couple other pieces of information from the domain controller. So we're going to go ahead and we're going to run this module, and we can see the cached ticket has been saved to disk. So at this point, we have successfully forged our ticket. Now, the Diamond and Sapphire techniques do request a ticket, so we did contact the domain controller for these ones. But to make sure that everything worked correctly, we're going to go back and use the Kerberos inspect ticket, which is going to allow us to decrypt it. Now, the AES key here, again, is the one that we had in our clipboard that we had extracted from the Windows Secret Stump module. With that in place, we can point it to the newly forged ticket, decrypt it, and we can see here that we have updated it to authenticate as the S.McIntyre user. So that server name being the KRB TGT, we can tell that this is a TGT ticket, so we can authenticate to different services as S.McIntyre by using this to obtain a TGS and be able to authenticate against whatever service it is that we would like to authenticate against. Now I would like to talk about our new sessions. So we have a number of new sessions that have been added to Metasploit. Now, traditionally, some of the most popular sessions that Metasploit has had have included the Meterpreter session, of course, one of everyone's favorites, one of the most fully featured sessions that we have, as well as shell sessions. We also have VNC sessions, and a couple of years ago, we even added SSH sessions, which support pivoting. This year, we've expanded that collection again with a few of the new protocol-based sessions. Now, these are really nice because they do not transfer up any kind of binaries onto the targets. The idea here being that if you transfer up like a Meterpreter session, or excuse me, a Meterpreter binary to open a Meterpreter session to a target, that Meterpreter binary is an attack surface for antivirus to fingerprint, to detect, and to block, something along those lines. These protocol-based sessions that are new are just a connection. We're not transferring up any payload. We're not writing anything to disk. We're not even loading anything in memory. We're simply opening a connection. So they're pretty limited in what they can do, but they have the functionality that is related to whatever protocol it is. So for example, SMB can be allowed to browse file shares. LDAP can be used to run interactive LDAP queries, as well as the database ones, including MSSQL, MySQL, and PostgreSQL can all be used to run database queries. So once you have the session established, you can go ahead and interact with the session and the protocol as you would expect to. Now, because this session is long-lived, you're only authenticating once, which is nice, so you only have that being placed into the logs once. But the other nice thing is that we can now run modules against these new session types. So some of our modules work by authenticating against a particular service, and they work exclusively with that service. So PSExec uses SMB to open a handle to the DCERPC service. It uploads a file, opens a handle to the service manager, executes that file to execute payload. You can do that with an SMB session now. Likewise, we have a half dozen, if not more, modules that are pretty new, utilizing LDAP to perform different types of queries. You can do enumeration on the target domain controller. You can look for vulnerable ADCS certificates. You can run a shadow credentials attack, all by authenticating against LDAP. So if you have an LDAP session open, you can now utilize these modules as post actions. I don't want to say post modules because these are auxiliary modules that you can now use against sessions. So we're kind of blurring the line here between what is truly a post module and what's not. Traditionally, Metasploit has considered post modules to be a module that works with a session. And so all the post modules were all organized together under that. But now we have this interesting pattern of PSExec is an exploit module, and there's a bunch of auxiliary modules that can now be reused against a session. So that can be a little bit tricky, but we've tried to make it a little bit more discoverable through some messages that you'll see in the demo output. So with that, let's go ahead and check out our second demo. So first up, a lot of these sessions can be utilized and opened through their login modules. Now you'll see down here the create session option needs to be enabled. But before that, for LDAP specifically, LDAP is the newest one. This one is a feature that has to be enabled. All the other session types are all enabled by default in 6.4, but LDAP is not. So you need to enable that feature in order to get this functionality to be available to you. Now, once you have enabled that feature and restarted Metasploit, you'll have the ability to go ahead and use the LDAP login module. And this time we're going to authenticate as the domain admin. So we have their credentials and we're going to open our session so we can go ahead and interact with it. So because we had the create session set to true, we can see that an LDAP session has been opened. And now we're able to go ahead and interact with it. Now we'd interact with it as if it were any other session, and we can see that there's only one command that's available to us to interact with it, and that's to run LDAP queries. So let's go ahead and take a look at what that might look like. But first, we also can see the list down here of all of the different modules that can be used with this session. So we'll go ahead and run a basic query. We're going to use -F to specify our filter. And then we can run our query, and we can see that was executed, and we have all of the output that's available to us. So if we wanted to go ahead and tweak our query, we can go ahead and do whatever we would like, and can go ahead and specify different attributes, the output format. We can go ahead and run whatever query we would like. So if using the LDAP query module isn't your preferred source, you can go ahead and run these queries interactively using the session. Now, with that in place, we can also go ahead and use a module. So we're going to go ahead and use the new shadow credentials module. Now that we have this module pulled up, we can see that we have this message down here saying that we can specify a session for it. So we're going to set it to -1, which is going to be the last session. And then we have a couple of different actions. And we're going to go ahead and set the target user for who we want to set the shadow credentials for. It's going to be that domain admin again. And so we can list this out. We can see that currently there are no credentials set up for them. But we also have the ability to add a credential, flush all of them, or remove a specific one. So we're going to go ahead and add one. And we have configured that. So we have the certificate down here. Now we'd be able to use this certificate to authenticate as that user as if it were any other of the PFX files, which you're probably familiar with if you have exploited any of the ADCS flaws or seen our work that was released last year. So now with that in place, we can see that the credential has been added and we can list it. Now we can also look at the new SMB session. So very similar, we're going to go ahead and use SMB login, and this time we're going to authenticate as a normal user against the domain controller. So we want to set create session to true because we want to get that interactive SMB session, and we're going to run it. And now we have an SMB session that has been opened. We're going to interact with it. And this is an SMB session, so we have a few different commands. SMB being primarily a file sharing protocol. We have the ability to deal with the file system, the remote file system. So we can't list any files yet, and that's because we need to select a share first. So we can list out the shares, and then we're going to go ahead and interact with the sysvol share. This being a contrived domain controller, there's not too many files in here, but we can go ahead and navigate around the file system. We can read and write to these files. We can upload and download files, assuming that the user that we've authenticated with has the necessary permissions. But we can go ahead and interact with the file system in this manner. Now, this being SMB, we can also go ahead and use modules. We're going to use that ICPR cert module, which is what we use to issue out certificates. So now this one also notifies us that we can set it to be used with a particular session. So we set session to be -1, and we're going to go ahead and set the options. We're going to leave the new connection options blank, but we still have to set a few other options in this case. So we're going to set the CA. In this case, we had already known the CA, but we could have dumped that using the LDAP query module. And with that in place, we're able to go ahead and issue out a certificate. So we can see here that we're using the existing session, and then we have dumped out our certificate. So we can use that certificate to authenticate as the mHatter user. Now for the last one, let's go ahead and take a look at the MSSQL login module. We're going to once again set create session to true, show out our options. So now if we want to use Windows authentication, I wanted to also call out that we have the password is set here, but we also set use Windows to true. So we're using the Windows authentication to allow us to authenticate as that domain admin account. But with that in place, we can go ahead and open our session and interact with it yet again. Now databases being primarily something that we would query, we can see the commands that we have available to us are a couple of different commands to allow us to interactively query the database. So let's go ahead and run a simple select query. So we're going to select the version to print out the version information of MSQL. So you can get that. In addition to that, we have all of the modules that we can go ahead and run. So let's run the enumeration module. So we're going to use the auxiliary admin MSSQL enum module. We're going to set our session and run that. And then we can see all the information that we are able to dump from the enumeration of that module. So now we didn't have to re-authenticate to the database server. We were able to reutilize that connection. All right, and now I would like to talk about the third major change, which is the DNS overhaul. DNS is everyone's favorite protocol. I'm sure it's always DNS that's causing everyone's problems. But Metasploit has had an issue with DNS that has made pivoting to be a little bit more complex than it needs to be and has had some OPSEC implications. So one of the things that Metasploit has had for a really long time is the ability to pivot. Now, when I say pivoting, I mean that when you open a Meterpreter session, if you're using the auto route plugin or one of the modules to go ahead and route all your traffic through that Meterpreter, that's our pivoting capabilities. So that introduces some problems when DNS queries are made from Metasploit, because DNS is typically handled through like a system API that integrates with your operating system, whether that be Linux or Windows or what have you. And that caused some difficulties, two difficulties primarily. The system resolver would resolve them from the host on which Metasploit was running, which constitutes a DNS leak. So if you were trying to run actions against a target through a pivot, you would potentially be looking up that target's name from the host on which Metasploit was running, which can leak where the Metasploit operator is on the network. And the other thing is that when you are pivoting into a domain, for example, if you're an outside attacker and you've compromised an internal host, and let's say the corporation has their own LAN, you may not be able to resolve those host names that are used on the internal corporate LAN, but the host that you have compromised can, because they can access the domain controller, which is most likely a DNS server, or there's another dedicated DNS server internally. So Metasploit has brought its DNS resolution capabilities internal into Metasploit and implemented it all in a Ruby stack and made it configurable for users. Now, most of the time, users probably aren't going to need to deal with it, but Metasploit has made this configurable for users to be able to set up various resolvers for use in different advanced scenarios, which I would like to cover. So first, the DNS system, the system DNS resolver would have like this type of an architecture where Metasploit would open a session on the compromised host and you'd be trying to pivot your traffic to the target, but Metasploit would still be issuing the queries to the DNS server. And that's where those two problems come in to play. So number one, if the DNS server that Metasploit is trying to use doesn't know how to resolve the target host name, you're going to have resolution failures. You're not going to be able to get your IP. You're not going to be able to initiate your connection, and you're going to have problems from there. And then the other thing is that the DNS server is going to see those queries coming from the host that's running Metasploit, which may not be desirable if you don't want to be, leaking where your position is coming from, who you're trying to connect to, that type of thing. What you want is you want the DNS queries to be coming from the compromised host, because that's also who is making the connection. Now, if the compromised host were connecting to target, without Metasploit's interference, it was normally connecting to that, it would be resolving the host name itself. So because that's where the connection is coming from, it's much more natural for that to be where the DNS queries are coming from. So Metasploit has integrated DNS into RecSocket, which I don't want to get too far into the low-level internals, but RecSocket is what powers the pivoting capabilities within Metasploit. So once that's configured, we can go ahead and run the queries from the compromised host. So let's go ahead and take a look at the last demo. So all of this functionality is exposed through the DNS command. Now, what we're looking at right here is the default configuration, and as I mentioned, 9 times out of 10, you probably won't need to change the DNS configuration from Metasploit. This is kind of a more advanced scenario that it really primarily useful in situations where you are pivoting. Now, we can see down here, it has automatically loaded up all of our hosts from my host file. That's why all of those are listed down there. But we're going to go ahead and we're going to try to resolve WS01, that workstation. So now we can't resolve it yet. That's because the host that Metasploit is using as my DNS server is using my system DNS, and it's not using the Active Directory domain controller. So what we're going to do first is we're going to go ahead and we're going to add a rule. We're going to place it into position 1, and we're going to say that any requests for msflab.local, which is that domain, are supposed to go through session 1, and they should contact the domain controller at 192.168.159.10. So we can see that that entry was added, and now we have our very first rule. Just like IP tables, the very first rule that matches is going to be the one that's used for sessions. And so if we want to go ahead and use the DNS query command a second time, we will see that the resolution works. We see that it matched rule number 1, and we are able to resolve that host name to an IP address, and we can see that it came through session 1. So now another thing that we have is we have a few different resolvers. So the IP address is going to be an upstream DNS server. We also have black hole, which will drop our queries. That is handy if you don't want to resolve a hostname to an IP address. Say there's something you don't want to touch, you can configure it through the black hole resolver, and all of the queries for that will be dropped. So we can go ahead and add that in as an example to position number 1. And we can test it out by trying to resolve test.notouch.msflab, and we can see here that even though it's from MSFlab, because the rule took priority by being in a higher position and it's the black hole, that the resolution failed. By extension, we can also place a rule for a specific host name, so we can say that we don't want to resolve this particular host. And if we go up and try to check one more time if we can query that host, we'll see that it actually works, but the reason why it works is that we actually have a cache that is integrated. So what we want to do is go ahead and flush the cache first. And after we have flushed the cache, we can see the desired results, which is that the host name is not resolving anymore. So we can print out our status. We have a few different rules configured now. We can go ahead and flush out the static host names as well individually. And now we just have the rules that we have configured, no static host names anymore. Finally, if you need to reset it back to its factory conditions, you can use the DNS reset-config, and what that will do is flush all of the rules, flush all of the host names, and then reload everything from the host operating system environment. So if you run into any issues, highly recommend using reset config. With that, I want to go ahead and say thank you very much for listening to me talk about the latest features in Metasploit 6.4. You can find Metasploit at our homepage at metasploit.com. Everything that I have demonstrated today is publicly available and has shipped on GitHub. Our repository is at rapid7/metasploit-framework. In addition to this, if you find that you want to know any more information about any of the features, we have documentation at docs.metasploit.com, and there is a 6.4 release blog hosted on the Metasploit blog site where you can find more information. And once again, I want to say thank you very much. This was Spencer McIntyre talking about Metasploit 6.4.